All right, class.
Yes.
Okay, good morning.
Good morning.
There we go. All right, there we go. A little bit better. I do class in my other class, and then I do morning for you guys because it's morning. All right, anyway. So, L'Hopital's rule for this. Now, the limit as x approaches 0, but what's that little plus sign mean? Do you remember that? From the right. From the right. Why is it only from the right? Because the left's what?
It may not be continuous.
Yes. So there's nothing on the left of this, right? Okay, what about 0? Is there an ln 0?
No.
Nope, there's no ln 0. So ln 0 does not exist. Okay? So we're going to go through and we're going to try L'Hopital's to see what we get. So if we're doing that, so that would be, if it's approaching from the right, you have to try and imagine. Okay, it's almost like I drew graphs on the board of what ln looks like versus e. So ln x and then e to the x. So if you're imagining it, you could see in your mind that ln x, as it's going from the right to the left, as it's approaching 0, it goes to what? It goes where? Negative infinity. It goes down to negative infinity, right? Okay, that's very good. So it goes down to negative infinity. So from the right, this goes to, I don't know what it goes to. All right, it goes to, there we go, negative infinity. All right, now cotangent. So cotangent is the reciprocal of tangent, right? Okay, so reciprocal of tangent. So now I got to think about it. So tangent at 0. Tangent is sine of a cosine. Sine at 0 is 0. Cosine at 0 is 1. Very good. Okay, so now that's tangent, but we got to flip it over. So it's got to be it's going to be undefined. So now cotangent is going to be 1 over 0. Okay? So now, since I don't have this one on the board, let's see what it's going to look like. Because this is going to be super important. You have to understand what the graphs look like. And so in your calculator, you guys are going to graph right now, please. We're going to graph what cotangent looks like. So if you have your calculator. Man, look at this. All these. Oh, goodness. What is wrong with people today? Dang. All right. I'm going to go and let's see. My mode. What mode do I got to be in? Got to be in radian. Okay, calculus, we always work in radian. So I'm doing cotangent, right? Cotangent of x. Right there. I'm going to hit enter. Ooh. Now, right here's at 0, isn't it? Yes. Right here at 0. Okay, so cotangent, as it's approaching 0 from the right-hand side, is going to be positive infinity. Thank you. Positive infinity. That's what I was looking for. So positive infinity. So you guys actually have to think about that. Now, is this one of my indeterminates?
Yes.
I have a list here somewhere. Where's my list? I have a list here somewhere with all of them. Yeah, infinity over infinity. Okay, so, yeah, there's a list somewhere. Infinity over infinity. So, this one, I could do this. So now we're going to do L'Hopital. So I take the derivative. The derivative of cotangent. It's almost like I gave you guys flashcards to practice this one. Okay. If you don't know it, what do we know? We know that it is cosine over sine, right? It's cosine over sine. So let's do the derivative then. If we don't know it, do the derivative. So if it's going to be cosine over sine, right? So that's a quotient rule, isn't it? So that's a quotient rule. I know we ain't playing with cell phones right now. Yeah, All right, so let's go ahead and do the quotient rule on this. So, derivative cosine is negative sine, right? Times sine minus, okay? So, derivative of sine is cosine, right? So it's cosine times cosine all over sine squared. All right, let's go ahead and put them together. So, if I put them together, that's going to be a negative sine squared minus cosine squared over sine squared. Okay. Now, I'm about ready to say an F word right now. You guys better catch that. Factor, what am I factoring? A top, what am I factoring out? A -1. You'll see why. You're like, hey, why is he doing that? Yes, it is. Sine squared plus cosine squared is going to give me 1, isn't it? Okay, good. Sine squared plus cosine squared is going to give me 1. So I could replace all that. So -1 times 1 is just -1, right? So it's -1 over sine squared. There we go. So my answer is going to be negative cosecant squared. So, if you do not remember your trigs, just remember, okay? You know what the derivative of sine is, and you know the derivative of cosine. You can make everything from that. Okay? You might have product, you might have quotient, you might have other things. As long as we don't have our cell phone out in our hand right now. Okay, so I'm going to go, this is going to be derivative. So this is going to be, what's it? Negative CSC squared x over. All right, I'm going to erase this part right here because we're just done with that. All right, now derivative of ln. 1 over x. I don't like fractions over fractions. I really don't. I do not like them here or there. I do not like them anywhere. So I would not, could not, in a box with a fox in the rain on a train. Okay, so I'm going to multiply by the reciprocal instead. So if I multiply by the reciprocal, and I don't like cosecant either. I do not like that. Is cosecant on my unit circle? Say no. No. It's the reciprocal of sine. I like sine. Okay? So I'm going to rewrite this using the reciprocals on both. So this is going to be 1 over, -1 over sine squared x times the reciprocal of the bottom, which is what? X over 1, right? So it's going to be like that, isn't it? Yeah. Okay. So now, can we try it now? Let's see. Let's see. So I'm going to have negative x over sine squared x. Let's plug in 0 now. This is probably a whole lot easier now. We can plug in 0. So the derivative of x is, I'm sorry. -0, right? So plug in 0, I get 0. And sine at 0 is 0. Ooh, hey, look. This is 0 over 0, isn't it? So that means that this is the Indeterminate. So if it's the indeterminate, I know that I'm going to do it again. Do it again. So if I do it again, the derivative of the top is going to be -1, right? Over derivative of the bottom is going to be 2 sine, right? Sine x times derivative of sine cosine x. Okay, so now that I have the derivative, can I plug it in now?
No.
Why?
Zero in the denominator.
Gonna have 0 again, right? Dang, that sucks. Yeah, it does, doesn't it? Okay, so what would I do next? Find the derivative again. Okay, so if I do the derivative again, that's a product rule, isn't it? Okay, so if it's going to be a product rule, okay, on top the derivative is going to be, say 0.
Zero.
Okay, 0 over. Now the product rule, 2 sine is going to be 2 cosine, right? X times cosine x, right? This is a product. I put a plus sign, right? Okay. Derivative of cosine is negative sine, isn't it? Q, why you give me a face like that? What's wrong?
Zero on top.
Okay. What's the derivative of 1?
0.
0, yeah. I just need the bottom to not be 0, right? I just need the bottom to not be 0. That's I can have 0 on top, I just can't have it on bottom.
Yeah.
And it can't be 0 over 0 either.
But we want it to be 0 over 0.
Only if I want it to be indeterminate so I could do the L'Hopital's rule. But at this point right here, I don't want 0 over 0. I want a number. Okay? I want a number. Yeah, because if I take a derivative again, I already got 0. Okay, alright, so now, so derivative cosine is negative sine, right? So we're going to have 2 sine x times negative sine x. And this one's going to be nice. So, sine at 0.
Zero.
0. So all of this right here goes away because that's all 0, right? Cosine at 0. 1. So it's going to be 1 times 1 times 2. 2. So my answer is going to be
Zero over two.
0 over 2, which gives me
Zero.
0. Okay. 0 is the number. I'm allowed to have that.
That's what I was trying to say. Even if you have a number at the bottom, it's just going to be 0 because there's 0 on top.
I just have to get a number on the bottom. Because if I don't get a number and I have another 0 over 0, I'm in trouble because I'm indeterminate and my top of my fraction doesn't have anything good. That's why.
It doesn't look like what does the
It doesn't look like what?
what does
Ah! Oh, you didn't need that, did you? Oh, yes, it works. 0 over 0 or negative, right here. It says right here. Is a number or infinity or negative infinity. Yeah, so it could be infinity or negative infinity. It still works.
so
Yeah, so look, here's another one right here where it actually says either real number or plus or minus.
Question.
I have an answer?
When do we use this in real life or like in science or in anything?
Do you know what? I use this in real life daily.
Yeah. How? Where?
Right here.
What if we don't become a teacher?
Okay, so now, listen. Math is one of those building blocks into other things. Okay, you want to be a biologist, right?
No. Astronomer.
Huh?
Astronomer.
Astronomy, even, you know what? Even more. A lot of this stuff comes into play. All the trigonometric angles, all the derivatives, all the slopes of the curves. Okay, like one astronomical unit. Okay, those things right there, you actually need to calculate this. So you will do it. You just have to understand what you are doing. So yes, you're going to look at something and be like, all right, I'm going to plug that in the computer. Yes, but you have to know what to plug in the first place. Okay, functions and stuff like this, you know, it's going to help you out. Okay, so yes, astronomy actually works it, biology works it a lot. Okay, this is a perfect growth model because we're taking a limit as it's approaching a certain number here, right? So the limit is going to 0, okay, as it's going from the right. Because if we're talking about population density or some population, we would actually look at it. We're not going to look at negative numbers for a population, right? Okay, no negative numbers for a population, but we will have positive numbers. So if we work our population backwards, we could actually see where it's eventually come first. And we'll eventually, so if you do the population backwards, you can find out that the chicken came first. All right.
What form of rhetoric was that?
What?
So what form of rhetoric was that?
You see, ethos because he's a math teacher with a degree and is explaining that it ties into pathos because it emotionally attaches to us, which then makes what he's
Logos,
saying.
he said, words.
Chicken came first.
Cool.
Okay. Is this one a L'Hopital right here? Say no.
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 Why is it not L'Hopital?
Because it doesn't have a denominator.
It don't have a denominator, right? Can we make it have a denominator?
Yes.
Okay.
1 over x, right?
That's derivative already though. I don't want that though. Huh?
The over one.
Not over 1. I don't like that. Because if you notice right here,
Over x.
over
X.
close.
Ln
X
of x.
squared. E. Eh.
You know, you guys are gonna feel you're gonna feel really, really bad when I show you this one.
Wait, go show Justin.
Does not exist.
Over 0.
He's the old one.
Start off. Wait, what?
Oh, yeah.
What's X to the
Oh, why?
Yeah.
This X right here, I still gotta have that X there, right?
Yes.
But if I put it down, now I could actually do. Now I could actually do this.
Yeah, why can't we put it down?
Because to have L'Hopital, I have to have a quotient. I have to have top and bottom, numerator, denominator.
Yeah, but like, that doesn't seem cool.
Okay, so think of it like this. To make that exponent positive, you would move it back up, wouldn't I? Yeah, it would become a positive back up here, just like this one.
Also, why would we want to do that? Why would we want to use multiple if we don't have to?
Okay, can you find the limit for this one?
Wait, no, it doesn't. Oh, because it does not exist. And time 0. Oh, okay, that makes sense. No, I can't.
It's not going to exist at 0, right? ln doesn't exist at 0, but 0 times non-existent is not going to help me out. But now if I set this up,
I'm over mine.
yes, you. What are you supposed to be doing? Paying attention. Where's your notes? Write crap down. No, that's homework. Don't even try and perpetrate like here. I hand you homework, or I hand you the notes. Where's those at? Bruh. Wait, hold on. Wait, I gotta do the meme.
The people on YouTube, I can't see it.
I know, right? Anyway. Okay, so now from right here. Now I have a quotient, and now let's see if I can plug it in. So if I plug this in right here at 0, right? This is going to go down to negative infinity, right? Okay, so that's going to be a negative infinity. And this one right here. So x going to 0. Okay? So if I'm doing it like this, on this one right here, I would rewrite it as 1 over x in the bottom, right?
Oh, yeah.
Yes? Okay. No, remember, we're approaching 0 from the right. Think about the numbers. So if I have 1 over 1, right? Okay, 1 over 1, that would be just 1, right? But now, we're approaching 0, so I want a smaller number. So, okay, so 1 over 1/2. No, 1 over 1/2. So 1 over 1 is 1. 1 over 1/2 is 2. 1 over 1/4 is... Okay, so as we keep getting smaller, yes, this is an asymptote right here, right? And so if you're doing it like this, you can see, like clearly see what numbers this is actually doing. Oh, it's going up, isn't it? Okay, so I have it written like this, so now I can look and say, oh, that's going up. So now this is going to be over infinity, right? So this one's going up to positive infinity. There we go. So now we do have a L'Hopital's on this now, right? That's what I was trying to get to. So now doing the limit, I could do the L'Hopital. Alright, so doing L'Hopital, so the derivative ln x is 1 over x, and the derivative of x to the negative 1 is
Negative 1x to the negative 2.
negative 1x to the negative 2. Very good. Yes?
Yes.
Okay, so let's do it again. Let's see what we get. So now I was plugging in 0. Okay. This one, so I'm going to rewrite it. Okay. It's going to be 1 over x times...
Negative x over 2.
Oh, remember. So this is a negative exponent right here, right? Can I rewrite this? Because I don't want fractions over fractions. Isn't this the same as saying negative 1 over x squared, right?
Oh, yeah.
It's the same as that. But then I want to fix it. Okay, I'm going to multiply by the reciprocal, right? Which is going to be a negative reciprocal x squared over 1. Very good. Okay, so now this is happy. Happy day right here, right? What's going to happen here? I'm going to cancel out one of those x's, right? Bam! Get rid of that. And now I'm going to be left with a negative x over 1. Now can I plug in my 0? Plug in 0 and I get 0. Equals 0.
Wait, what is what are you using it to find?
Okay, we're finding the limit. L'Hopital is to find limits.
Oh, okay.
It's always to find a limit. Okay, back when we did, chapter 1 and 2, when I was having you guys find limits, you had to do it all algebraically, all long, right? But a lot of the problems, you could go straight to L'Hopital and just do it right away. Now that you know how to do a derivative. So if you know how to do a derivative, L'Hopital is easy. Yes?
So what we're finding is what the limit is.
Yes, the limit. So what is this approaching, okay, as this goes to 0? This function right here is approaching 0 from the right-hand side. So my limit is going to go to 0. So again, see that right there? The chicken came first.
That's an egg.
Yeah. So there's an egg there, right? Okay. So chicken came first. So it's approaching that. So anyway. All right. Like, share, and subscribe. You know what? I guess I could finish this tomorrow, right? I got like 2 more slides, 3, 4 slides.
Yay.
Yay. All right.